let's get to the board so everybody can swing this out this way, actually.
That's a smart idea.
Yeah, don't give me too much credit. I got lucky with this one. All right, Jessica, we're back. Okay, everybody. So, for years, when I've taught statistics classes, we've done a hypothesis test, which is just a fancy word for we had a hypothesis based on M&M's milk chocolate candies. And as it turns out, I learned all kinds of fun stuff about them. They're actually made in two different factories. One's in Hackettstown, New Jersey, which is a town I hope you never have to go to. And the other St. Louis, Missouri, which is another town I hope you avoid with all your being. So, but the ones from Hackettstown are in this percentage. So in other words, when you crack open a bag of milk chocolate M&Ms from laptops, we're gonna use them later. When you crack open a bag of milk chocolate M&Ms that come from the Hackettstown plant, and the colors fall out, you should see these percentages of the colors. That's what they say anyway. Now I've tested this for years. If you've ever been to my office, actually, right near where your homework is, that I put the homework folder up there, if you look to the right of that, there's a series of clipboards. There's two clipboards. On the left clipboard are all the letters I have sent to the Mars company, telling them why their percentages are wrong, because I used to test them 3 times a year, and they never match these. And in the right clipboard are all the response letters I got back from Mars that are form letters. They say the same thing every time. Thank you for playing. Here are the percentages. We appreciate your support. And my letter always says the same thing. It's like, at least 1 or 2 of your percentages is off. Could you please send us more candy so we can test it again? And in 2007, I got a rejection letter from them with a $5 coupon, which I was so excited about. And I clipped the letter and the coupon to that clipboard, very first letter I ever got back. And somebody stole the coupon. I have no idea where it is now. Somebody walked off, bastards. And then ever since then, I haven't gotten a coupon. I just keep it in the letter. So I haven't run the experiment. I haven't taught that class in a couple years, but unfortunately, but that's okay. We're going to use those numbers as gospel, so to speak. So I said, suppose your factory produces 100,000 M&M candies a day, and those are the percentages we're supposed to have. How many brown would you expect? How many brown would you expect, Nika?
12,500.
Tell me how you came up with 12,500 brown.
Because I did 100,000 times 25%, and I got 25,000, and then I divided that by 2, which got me 12,000.
That's clever as hell. So here's one. I was kind of doing with this one. I made the numbers nice because I wanted to focus on procedure. So that's why I used the number 100,000. So I want you to focus on what Nika just said. Very, very slick. She took 100,000, and then you multiplied it by, you said 0.25, which is the 25%. And got 25,000 from that. But that's 25%.
Right.
So then she took that and
I added the brown and the red to get 25%, and then I divided it by 2.
and then she took, because this is 25%, she divided it by 2, because half of 25% is 12.5%. Very nice. So you divide that by 2, so you get 25,000. Divided by 2 to get 12,500. I love it. Is there any way we could have done it to get it directly without having to do that divide by 2? Larry, go ahead.
Multiplied the 100,000 by the actual numbers and then moved the decimal place over 2.
Yep.
I was trying to keep up with you. Multiply.
Times like 12 and a half.
12, okay, here's a second method. Larry said to multiply by 12 and a half.
And then move the decimal place back over 2.
Why?
Because it's 0.125.
Because it's 12.5% per 100. So moving the decimal place back 2 is the same thing as dividing by 100. So using the language of, whenever I talk about moving decimals, it confuses some people sometimes because they wonder, okay, do I have to move it left or right? Don't ever wonder. Just let the math do it for you. It's kind of like when I always say, look at the units, focus on the units. I say the exact same thing with this kind of a thing. Focus on this. So when you take 100,000 times 12.5%, you're going to end up with 12,500. Larry, you also said a third method. I'm going to write that on the board too, if that's okay. He also, in discussing this, said you can also do it this way. Take the 100,000 and multiply by 0.125. which is the same thing as this. Those are the exact same thing. No difference. No difference whatsoever. Thank you, my friend. 3 different ways. How many of you did method 1? Nika, that was fantastic. That was really cool, actually. What I really like, too, about your method is you got all the answers for all of them through this one, didn't you? Because you got the 25% right off the bat, so you know for a fact, I forget the colors now. Which ones are 25%? Orange and blue, so you know each of those should be about 25,000. And all the other ones should be about 12,000. Thank you, absolutely. Amber, please.
I did it way different.
Tell me.
I took 50,000 and divided it by 2 for orange and blue, and then 50,000 and divided it by 4 for the other.
God, that's badass. That's totally badass. So in other words, you focused on the pie chart itself. So you've got this 100% of all M&M candies, and then Amber focused on the fact that half of them, was it orange and blue or the half? Orange and blue. And then the others got cut into quarters,
But they were still equal. See?
but they're still equal. So in other words, you can take half of the pie chart for orange and blue, and this half right here is 50,000 candies. And then this half of the pie chart over here is also 50,000. And then to figure these out, you divide them by 2, and to figure these out, you divide them by, I love it. That's fantastic. Can anybody think of a case? Oh, this is so good. Can anybody think of a case where Amber's method wouldn't work, but one of the other methods on the board would? Not this. Clearly it works here.
If they weren't equal.
And here's the thing, if I may. I wasn't planning on going this route. It's really loud, I'm sorry. If we look at the other plant, the St. Louis, Missouri plant. Pull it up so you can actually see it. Yeah, maybe school things. It's my old 58 lab. We don't do anymore. We're not going to get to it, I should say. M&M's, here we are. So here we go. These are all the different color distributions that Mars has told me their candies have been in the past. So for example, there's your Hackett, that's the one you just did. That's Hackettstown, New Jersey. 25, 25, 12, 12, 12, 12. Cleveland, I was wrong, it wasn't St. Louis, Missouri, it was Cleveland. Home of the Indians. I just watched the movie Major League over Thanksgiving break, one of my favorite movies of all time. Better teach his kids to control before he kills somebody. Look at these percentages. Look at these percentages. They're kind of hard to see. I'm going to make them larger. That's too big. So you got 13.1%, 12.4, 20.5, 20.7, 19.8, 13.5. Why they are these percentages, I have no idea. But this is what the letters that come back to me always say. These are the actual percentages of the candies that come from the Cleveland plant. I don't know why they're so different than what these are. I mean, one's in Ohio, one's in New Jersey, but whatever. And then here, these are the actual percentages they used to give me back in the day. I don't know if you can see those or not. This is pre-2016. In 2016, they branched out and they started manufacturing different percentages in both of the factories. Again, I don't know why, they just claim to have done that. Now, so those are the percentages that we're stuck with from the Mars company. Here is what I actually see when I do the experiment with my students. Those are the percentages I actually see. So you can see how they're close-ish to what they say they should be. For example, according to the Hackettstown, New Jersey plant, there should be more orange and blue. More orange and blue. Now, looking at mine, there's more green and blue. But how different is 19% than 20%? And the question is not how different 19 is than 20%. My problem is that if there's supposed to be 12% and there's instead 20%, that's a fairly large difference, which is why I write them letters all the time. I do all kinds of statistical analyses on them. There's the actual data we collect from term to term. That's what the candies look like that particular term in the bags my students opened. And then here I do some analyses this way, and then eventually I run some tests. But they never match. As a matter of fact, in all the years I've done this experiment, here's all the data I've collected, back from fall 2006 to, it looks like I did it with my friend Lee Ann last year, I think. Yeah. All the data I've collected over the years. Only 1 year did they actually match what they were supposed to match. That's it. Only 1 year. And every year I write a letter. I say, hey, just so you know, The percentages you say you're supposed to be having are not what you're supposed to be having. And I get the form letter back up here that says, thanks for playing. We appreciate your interest in M&Ms. Here are what the color distribution used to be. And I'm like, are you listening? I'm telling you they're not right. Thank you for playing. We appreciate your interest in M&Ms.
I'm pretty sure you're just getting a robot.
Oh, yeah.
There's a different name at the bottom of every letter.
So I could
So
still
they
be a
can change the
robot.
robot's name.
Yeah. They could
You think a
still-
robot signed a letter in 2006?
I don't know. Oh, like it's an automatic.
Some of y'all weren't even born then. I'm kidding. No, you're not that young. You're not that young. But the idea being is it's a form letter for sure, Amelia. You're absolutely correct. It's a form letter.
I doubt they
Copy
actually.
paste.
I got a feeling that there's actually, somebody found a picture of me online, and now they throw darts at me. But there is that letter come in from Bend, Oregon, that says, Sean Rule, Central Oregon Community College. Oh, here's that asshole. Here he is again. Here he is again. Anyway, it's been a fun data collection to analyze in stats classes. So those of you taking stats classes later, this is the kind of stuff you end up doing. It's pretty rad. It's pretty rad. I'm gonna go ahead and save those changes. Okay. Cool, making sense? So thank you, Amber, for realizing your method is super slick. Absolutely super slick. The only downside is it only works when the numbers divide up evenly, but that's why, oh, I gotta cover the screen, hang on. That's why we can use these other methods. All these methods are equivalent. It's just that ones like this one, I particularly think this one and this one are the most universal. Nika, yours is slick too. But the only reason it works is because 12 and a half is exactly half of 25. If it were something like 13 or 16 or 17, you'd have to come out in a different way. But that's why we do it different ways. Cool, give me those warm-ups. Thank you. Thank you, friend. Gimme, gimme, gimme. Gimme. Yeah, gimme. Oh, a Christmas tree, you did.
I was gonna ask you what.
That's okay. You know, I have more hair actually. Put my hair in a Christmas tree. I color it green, put little lights in it.
I would actually do.
Did you not get one? Oh, you did. Okay, good. That makes me all right. Did I get y'all's?
No, we didn't get
Did not get y'all. Turn this off.